Okay, so we just finished going over the homework, so if you were not here today, take a look at the posted notes and you can see the answers for the homework. But yesterday we talked about this. If events A and B are independent events, then the way we find the probability of A and B is the probability of A times the probability of B. So, two events are independent if and only if, that's our IFF, if and only if their joint probability equals the product of their probabilities. So, what does this symbol mean? Intersection. So, this is only true if their joint probability is equal to the product of their probabilities. Now, with independence, the probability of an event occurring is the same as the conditional probability. Okay? And the way we find conditional probability is the probability of A and B happening divided by the probability of B. And this also goes the other way. The probability of B would be equal to the probability of B given A if we have independent events. Okay, this is going to make a lot more sense when we look at our tables today. We're going to focus on the tables. Okay, so what does this symbol mean? Intersection, and we could replace it with what word?
Joint.
And. Okay, so this is intersection, and we can replace it with the word and. So this is for independent. Independent. Okay. With our dependent, this is how we find the probability of a dependent event. The probability of B given A is the probability of A and B divided by the probability of A. Or, this was the same from the other side, the probability of A given B would be the probability of A and B divided by the probability of B.
Sorry, I almost swallowed my last tip.
So we'll forgive you.
It was in my mouth and I almost swallowed it.
Alright, so let's get back to our workbook from yesterday and let's see what page this is on. These are some of the things we skipped yesterday. We're on page 444. Not 444, 441.
In our workbook?
Yes.
Right here? Oh, I think you
Oh God. Oh God. Oh God. Chris, that's not fun.
Okay, so here we are on 441. And it reads, an airport employee collects data on 180 random flights that arrive at the airport. The data is shown in the two-way table. Is a late arrival independent of the flight being an international flight? Why or why not? So we have all the information we need right here. So it says let A be the event that the flight arrives late. Let event B be the event that the flight is an international flight. So we're going to use the formula we just looked at to see if this holds, if this is independent. So to find the probability of A, we're going to find the total number of flights, which is given to us. Really nice, isn't it? You didn't even have to add it up. So there are 180 flights. And how many of those were late? 18. So the probability of event A occurring is 18 over 180, which is 110. Okay, so now we're going to find the probability of A given B. So how many international flights are there? 60. Of these flights, how many were late? 6. So the probability of A given B is 6 over 60, which is 1/10. So if we compare the probability of event A occurring, so the probability of event A, we said, was 1/10. And then we did the probability of being late given that it's international. So the probability of A given B was 1/10. Did it change? No. So what did we just talk about right here? If the probability of A is equivalent to the probability of A given B, what does that help us prove? They're independent.
Would that be enough for people who we have
You would want to show 2 ways, and we could do that. But if you show me one on the test, we're good with that. Okay, let's look at example 3. So we're going to flip over. We did 2 yesterday. Let's look at 3. Oh, I didn't answer that one, did I? So how would you answer this one? What would you say? Because the probability of A is equivalent to the probability of A given B. And what would we say about that? What does that mean?
That means,
If it's A and B or what? Independent.
independent.
Okay, let me ask you questions. If I had given you all this yesterday, would that have sent you for a loop? Did we do okay the way we did it? Saving
Yes, if you'd have seen it all at the same time, I don't think I would have done it as good. Like, I would have been able to
Okay.
comprehend as much
Right. So
information at the same time.
okay, so now we're on to example 3.
I agree.
And we have the same type of information. It's flights on time, flights late. And this time, what are we looking at? Show that a flight arriving on time and a flight being a domestic flight are independent. Okay, let's see what you can do with this and see what you come up with. You try working through this problem quietly at your desk.
I think we're going to try this one.
That's what you're supposed to do. So that was on time. Yes.
Okay, so as you work through this, do you see how this example is working through the other part of the definition we had? That the probability of A and B is equal to the probability of A times the probability of B, if and only if they're what kind of events? Independent. So here it talked us through that part. We had a total of 180 flights. Probability A was that they arrive on time, so 162 out of 180, which is 9/10. Okay, event B was that the flight was domestic, and so 120 out of 180, or 2/3, are domestic. And then, do you see how this last one, on-time domestic flights? So how many on-time domestic flights? Now we're inside the table. We're looking at this number, on-time and domestic. So this right here is going to give us the probability of A and B, because we're reading inside the chart. Does that make sense? So on-time and domestic is at 108 out of 180. It's 3/5. So this is the other way. If the probability of A times the probability of B is equivalent to the probability of A and B. Well, A is 9/10, B is 2/3. Let's see, this cancels and gives me 3. This cancels and gives me 5. Are they equivalent? Yes. So what kind of events are these? Independent. All right, now let's go back and look at our dependent. To find the probability of B given A, it's equivalent to the probability of A and B divided by the probability of A. The probability of B given A is the probability of A and B divided by the probability of A. It's a little easier when you have a chart. And here it is again. The probability of B given A is the probability of A and B divided by the probability of A. So this, we kind of skipped this part yesterday, didn't we? We skipped the formula part because we didn't need it for what we were doing yesterday. But we're going to add those back in today. All right. I'm going to, well, no, I'm going to skip that one. And let's do, what time is this class over? I've got to learn the schedule. Oh, we're doing great. Okay, good.
What time is it?
This class isn't over till 11:24, and it's only 11:07. Okay, let's flip over to page 445, and we're just going to look at number 1 right here. And then I have a worksheet that we're going to work through the front together. And then the back will be for your homework. Okay, number 1 says, a farmer wants to know if an insecticide is effective in preventing small insects called aphids, from living on tomato plants. The farmer checks 80 plants. The data is shown in the two-way table. Is having aphids independent of being sprayed with an insecticide? Why or why not? Okay, so what is the probability of having aphids? So we'll let A be having aphids. Okay, so how many plants had aphids? 26 out of how many plants did we have? 80. Okay, now let's let B, is it independent of being sprayed with insecticide? So we'll let event B being sprayed with insecticide. Okay, so what is the probability of A given B? Okay, so given B means we're only looking at this column, that row, doesn't it? So, what is the probability of A given B? So, having aphids 12
seconds.
given insecticide, 52. Are those equivalent? No. So, what kind of events are these? Well,
Independent.
actually, they are not independent, so there's some dependence there.
I have a question.
Yes.
I'm kind of blurry on the part. I don't where.
A given B.
Yeah, I don't really
Understand it.
I don't like. I'm blurry.
He's blurring everything.
Okay, so A given B means B happened. They were sprayed with insecticide. So when it says A given B, we're only looking at the things that fall into that category.
Okay, so don't worry about the second letter.
You don't even worry about the rest of the table at all. Only the things that fall into the sprayed with insecticide category. That is the only, in this case, row, sometimes it's a column, that we're looking
Okay,
at.
and question also, is there going to be a time where it's going to say A not given B? Because I don't really understand that.
If it's A not B, then we would be looking at
The whole
this
table.
row.
Is there going to be a situation like that?
Could.
I don't know how I would
Be,
understand that.
not being sprayed.
Wait, A not given B. Wouldn't that just be like the whole table?
Y'all want to just make up all sorts of new math today?
Well, as long as we're not going to
How,
have to do
how
like
about
tests, I don't care.
how about we just focus on what we do have to do?
Alright.
Okay.
Okay.
All right. So let me hand out today's worksheet and let's walk through this together. This was Unit 4 last year, and we rearranged the units.
Yeah, this one looks like
And instead of printing out a new copy, I just went up with last year's copy. That's why it has a big fat one written over 4, if you're wondering. Okay, go ahead and read the scenario, and then we'll walk through it together.
Christian, your backs are wrong.
Okay, so let's create your tree diagram. We have SMHS students and we have those that want to go to Jupiter and those that do not. So
Well, that's not a big tree diagram, is it?
it's about to be. So these are the ones that would like to go to Jupiter, and these are the ones that do not want to go to Jupiter. Okay, how many wanted to go to Jupiter?
36%.
36%. Actually, the J could go. And so how many did not want to go to Jupiter?
60%.
64.
64%.
Well, it says 60.
Nope.
Yeah, it says.
No, wait, no, it says that 60% were not seen.
Okay, so of those that wanted to go to Jupiter, 60% were not seniors, right? So we would say 60% were not seniors. Just trying to be an R. Maybe he's not. Okay. So how many were seniors?
30%.
40%.
40%. Sorry.
And of those that did not want to go, 30% were seniors. So how many were not seniors? 70%. Okay, we got a tree diagram.
Is that it?
Now, we're going to use our tree diagram, and then we're going to create tables, and we're going to use those. So first, let's take a look at our tree diagram. What is the probability that a randomly selected student wanted to go to Jupiter?
36%.
Okay, so just a student random wanted to go to Jupiter. We can read it straight off. It is 0.36, right?
Indeed.
The probability that somebody wanted to go to Jupiter is 0.36. Now, the next one says, what is the probability that a randomly selected student was a senior and wanted to go to Jupiter? So a senior and wanted to go to Jupiter.
Well, only 30% wanted to go to Jupiter, and of that, 40% were seniors.
So you gotta multiply.
21.6.
We gotta do some multiplication.
Yes.
Okay?
21.66.
So a senior and wanted to go to Jupiter, how would we find that? We would have to do the 0.36
Times.
Times.
4
the 0.4
equals.
of senior. And we get 0.144. Okay? What is the probability that they were a senior?
Out of what?
That a student was a senior? How would we figure that out?
0.4 times 0.3.
What could we do?
Oh, do you figure out the
Multiply.
percentage of
Oh,
not wanting to go to
0.4
Jupiter
times
and being a senior?
0.36.
Probability that they were a senior going to Jupiter plus the probability that they were a senior and not going to Jupiter. Would that do it?
Yes.
Yep. Okay, so this is how we get, I should have put the probability that they were a senior right here. Okay, so a senior and Jupiter, didn't we just do that one? 0.144. Okay, let's see if y'all can do this. A senior and not Jupiter, what is that? 0.192. Okay. 0.192. So what is the probability that they were a senior? 0.336. Okay, are y'all all with me? I know some of you are, because y'all are the ones that are talking to me.
Yeah.
Okay.
Wait, what was the answer?
Yes, I got that. I'm on board.
Okay,
you wasn't
D.
copied like you
No, I didn't. I just did it in my calculator. Look.
Yeah, did we just do that?
Yeah, we did that. Yeah, we did that.
This time they have to be a senior
Oh,
that wanted to go to Jupiter.
Just
Just senior. Okay,
Well, A
so
is
now that
actually
we've
a
done that,
student.
you want the probability that a Jupiter given a senior.
Oh gosh.
This is the definition we just did. This would be the probability of J and S given the probability of S. This is a conditional probability.
What?
So that a
I'm shutting down.
no shutting
I'm
down.
shutting down already, Miss Williams.
No shutting down. This is this formula, guys. Woo! It's our conditional probability formula.
But,
The probability of B given A is the probability of A and B divided by the probability of A.
but A, B, and
So
C
this
are
time,
the same.
it's not B and A. It's the probability of Jupiter and a senior. So the condition is senior. So this is a conditional probability. Jupiter given senior. It's the probability of Jupiter and senior over the probability of senior. We've done Jupiter and senior. What was Jupiter and senior?
What, 144.
0.144.
Oh.
And we just did probability of senior. And so that is,
Well, I wouldn't think of that if I was on my own.
I don't know if I know how to set that.
after you do a couple of them, you will.
Okay, hopefully.
Okay, so this one is a junior wannabe. A Jupiter wannabe was a senior. So what is the condition this time?
That they want to go to Jupiter?
That they want to go to Jupiter. So this time it's the probability of senior given Jupiter. You try.
Oh gosh. What if I didn't shut down yet?
Senior given Jupiter.
Jupiter wanna be a senior. What?
Quite frankly, I'm not trying to be like Debbie Downer, but I really don't even know where to start.
Yeah, I'm up.
Well, I don't know. What's a wannabe senior? Jupiter wannabe was a senior.
Okay. So this is the probability of
I don't even know.
junior and senior divided by the probability, not junior, Jupiter and senior divided by the probability of Jupiter.
Oh, so this doesn't
Probability
matter.
of one-
Jupiter.
Okay, we're about to get to the two-way table, except the bell's about to ring.
Yeah, and
So I'm going to finish recording this, guys, and you watch the last 5 minutes of the video, okay? Because the bell's going to catch me. Go ahead and get your phones, and
We have to try.
I'm going to finish this. Okay, do not do the book work. Your homework is to watch the last 5 minutes of the video and finish the back of the worksheet. Do not do the book work.
I don't even know where to start.
Like if I had to like go on my own, like Jupiter wannabe was a senior. Question mark.